Hello dear students, welcome back to Happy Learning. Today we are going to learn chapter 7 from class 9 triangles. Exercise 7.1, the remaining part, that means the question number 4, 5, 6, 7 and 8. So let us check the question number 4. Here L and M are the two parallel lines, that means L and M are the parallel lines intersected by another pair of parallel lines P and Q. So these two parallel lines are intersected by another two parallel lines, that is P and Q. What we have to prove, show that triangle ABC, that means this triangle, and triangle CDA, these two triangles are congruent. That's what we have to prove. What are the clues they given? They said these two lines are parallel and also these two lines are parallel. That are the things they given. With the help of that clue, we have to prove these two triangles are congruent. So how to do? Let us look carefully the figure. Okay, because from the figure itself, how much carefully we are observing the figure, we will get the solution from that itself. Okay, so here they said these two lines are parallel. Suppose if we are taking these two lines are parallel, okay, that means this is P and this is Q, and AC is the transversal. Okay, AC is the transversal, we can consider, no, because they said these two lines are parallel. So if these two lines are parallel and this is the transversal, so this angle and this angle, they are equal. No, what is the reason? Alternate interior angles. That means here we can take this angle and this one, it is equal. What is the reason? Because of alternate interior angle. Then how we got they are alternate interior angle? From the clue. What is the clue? These two lines are parallel. Okay, now take the another clue. What they given? L and M also parallel. So if we are considering the parallel lines like this way, okay, and if we are taking the transversal like this way, so this angle and this angle, that are also equal because of the same reason, alternate interior angle. So that means this angle and this angle is also equal because of alternate interior angle. Okay, so we got two angles are same. Okay, now we just look the third side, that means this side, this is common. No, for this angle and this angle, that side is common. Okay, so what all things we got? Two angles we got: angle, side and angle. Okay, angle, side, angle, angle, side, angle. Okay, so because of that congruency, we can prove that these two angles are what? These two triangles are what? Congruent. Okay, so this is the logic and this is the way we are going to prove, or that means we are going to write the statements. Okay, so let us start. I hope you understand which way we taken. So whenever these type of questions are there, first of all, very carefully we have to observe the figure, and who will help us to find out the solution. They itself will give the starting points. They itself will give the clues. From there we have to start. Okay. So here we are considering solution L and M. They are parallel. Okay, L and M are parallel. Okay, from that what we are getting? Then P and Q, they are also what? Parallel. So from that what we are getting? AD parallel to BC and AB parallel to DC. These two we are getting. Okay, now we are starting. So which two triangles they said that we have to consider? So in triangle ABC and triangle CDA, these two triangles we are considering because that two triangles are congruent. That's what we have to prove. So we are considering that two triangles. Now this is our first triangle. In this angle BAC. BAC. That means this corner. Now we have to take this corner. That two are equal. That means angle DCA. These two are equal because of alternate interior angles. Alternate interior angles are always equal. Okay. Now this side we are taking AC common. No? So AC, here also AC, here also AC. Look, AC equal to AC because of that is the common side. That is the common side. Now this is our first triangle. In this, corner C and corner A are equal. So which way we have to write? Angle BCA is equal to angle DAC. DAC. Same reason. Alternate interior angles are equal. Okay. So this is side and this is the this is the angle, this is the side, and this is again angle. So angle, side, angle. With that criteria we can see these two triangles are congruent. So therefore triangle ABC congruent to triangle CDA by angle, side, angle criteria. Hence we proved. Okay. Now move on to the fifth question. Line L is the bisector of an angle A. That means this is line L. Angle A bisecting. Bisecting meaning it is what? Equally dividing. Okay. So these two angles are what? Equal. Is any point on L, BP and BQ are perpendiculars from B. That means BQ and BP, these two lines are perpendicular. Perpendicular means here the angle forming it is 90 degree. So these two angles are also equal. Then show that triangle APB. Where is triangle APB? APB. That means this triangle and triangle AQB. AQB. These two triangles are congruent. That's what we have to prove first. Secondly, we have to prove BP equal to BQ. BP equal to BQ. That means these two lines are equal. That's what we have to prove. Or in other sense, B it is equidistant from the two arms. These are the two arms of the angle. So B it is equidistant. That means in other sense we have to prove these two lines are equal. BQ and BP. Okay. So these two things we have to prove in this particular question. So we will start. Okay, what are the clues they given? They given the clues. These two corners are perpendicular. Okay, that means the lines are perpendicular. So the angles are 90 degree. That is the first clue. Second clue, the line L is the bisector of angle A. That means QAB and PAB. That means these two angles are equal. These are the two clues they given, and we have to prove these two triangles are what? Congruent. So let us start. So we can start in solution. Which are the two angles we have to consider? That we have to write in triangle APB and triangle AQB. Okay, so we consider these two triangles. Now what all things we know? We know angle, this one and this one. They given, no? So we will take which angle we are considering as the first one? This one. So here we can take this is 90 degree. Okay, so angle APB is equal to angle AQB equal to 90 degree. Given. Okay. Now we can take these two angles. These two angles are equal. That also given. Which way they given? L is the line of line which is passing, bisecting the corner A. Okay. So we can take that also. So first triangle is this. So this is the corner. So angle PAB is equal to angle QAB. Okay, what is the reason? L is the bisector of angle A. L is the bisector of angle A. That is the reason. Okay, so two angles we got. Now which one we can take? Now AB, the side that is common, no? AB, for this triangle also AB is there, for this triangle also AB is there. Look, here also AB and here also AB. So we can say that side is common. So AB is equal to AB. Reason it is what? Common. Now here this is angle, this is also angle, and this is side. So AAS, because of that criteria we can say these two triangles are what? Congruent. So therefore triangle APB is congruent to triangle AQB because of criteria AAS. Because of this, that two triangles are congruent. Question not finished. One more part it is there. BP equal to BQ. BP is equal to BQ. That two are equal, no? Because already we said the two triangles are congruent. Okay, so if these two triangles are congruent, which are the sides and angles we not mentioned, they are also equal. Because of what reason? Because of CPCT. So we can say the second one's answer. This is the first one. Now second one's answer we can write. Which one we ask? BP equal to BQ because of CPCT. Okay, because of CPCT they are equal. Since these two triangles are congruent, so CPCT. Okay, these two sides are equal. Or we can write what? B is equidistance from the arm of angle A. That also we can write. Or B is equidistance from the arms of angle A. So hence we proved the two questions what they given. Okay, so question number 5 is over. Now move on to question number 6. AC equal to AE. AC equal to AE given. These two sides are equal. AB equal to AD. AB is this, that is equal to AB. These two sides are equal, given. Then one more information is available. Angle BAB. BAB, that means this corner, and EAC. EAC, that means this corner. These two, not complete way. This one and that angle are equal, given. 3 informations given. Okay, 1, 2, 3 informations given. And what we have to prove? We have to prove BC, that means this bottom side completely. BC is equal to D. Okay, so these two sides are equal. That's what we have to prove. Okay, so from this, which two triangles we have to consider? How we will understand? Through 3 clues they given, but directly they not said this triangle and that triangle are congruent. That what we have to prove. That they not ask. They are asking these two sides are equal. Okay, so these two sides are the parts of the triangle ABC. That means triangle ABC. ABC. So BC is coming in the bottom. Okay, now if we are considering the triangle this way, ADE. So there also the bottom it is coming DE. So if we are considering the triangles these two way, okay, and if we are able to say that two triangles are congruent, then by CPCT we can say these two sides are equal. No, that is the logic behind that. Now we have to think how we can say these two triangles, or how we can prove these two triangles are congruent. Okay, so here, before that consideration of that two triangles, here we have to take the angle, this one, BAC. D they given, but we needed the full angle, no, the complete angle we needed when we are considering triangle ABC. So the complete angle we needed. Okay, that means from here to here we need. Okay, and if you are taking the other triangle, there also we need this full angle we need. Okay, so in that what part is common? This part is common. Okay, so with the both that two triangles we are going to add that common part. So what will happen? Let us look. So here angle BAD, okay, this is equal to given. This is equal to angle EAC. This is given. Okay. Now both the angles we are adding. Which angle we are adding? This shaded part. No, that angle we are adding. That is angle DAC. Adding angle DAC to both the side we are adding, both the angle, actually both the angles we are adding. So angle BAD plus angle DAC equal to angle EAC plus angle DAC. We added. Okay, now after addition what we will get, when we are combining these two angles we will get the full angle, that means BAC we are getting. So when we are adding these two we are getting angle BAC is equal to this full angle, this one, look, EAC means this part and DAC means this part. Okay, so that means the complete this side we are getting. So that's what we have to write. So angle DAE. Okay, so these two angles are equal. That's what we are getting, because equals we are adding with the equals. So the result is also equal, no? So in that sense we got this. Now we are considering the two triangles. In triangle ABC, in triangle ABC and triangle DAE, these two triangles we are considering. In these two triangles, AB is equal to AD, because AB is the side of first triangle and AD is the side of the second triangle. Okay, they are near, they are consecutive, but they are the sides of the two different triangles. Okay, so we can take AB is equal to AD. AB is equal to AD. Okay, then this is given. This is given. Then we can take this angle. Angle BAC is equal to angle DAE, proved above. Here we proved that. It is not given. It is not given. We proved already here. Proved above. Okay. So side we taken, angle we taken. Now the another side. Another side, from the first triangle's side is AC. Second triangle's side is AE. Okay. So AC is equal to AE. This is also given. This is also given. Look, given. Okay. So here this is the side, this is the angle, and this is the side again. So by side angle side congruency, we can say these two triangles are congruent. So therefore triangle ABC is congruent to triangle DAE by side angle side criteria. Okay, but here the question, it is not prove these two triangles are congruent. Question it is what? These sides are equal. That what we have to prove, BC and DE. So hence these two triangles are congruent. That means the sides and angles which we are not mentioned, they are also equal because of CPCT. So we can write therefore which implies BC, the side of this side, that is BC. Here it is DE. These two are also equal because of CPCT. and hence proof is over. Okay. Question. AB is a line segment and P is its midpoint. AB is a line segment and P is the midpoint. If P is the midpoint, its meaning it is what? These two sides are equal. No. AB's midpoint, if it is P, then these two sides are equal. Okay. Now D and E are points on the same side of AB. D and E, these are the 2 points. D and E are the same side of AB, such that angle BAD, that means this corner, and ABE, that means this corner. These two corners are equal. One more angles are equal, these two. Angle EPA and DPB. These two corners are also equal. Okay. So total 3 clues they given. One, it is P is the midpoint. Second one, these two angles are equal. Third one, these two angles are equal. Now what we have to prove? We have to prove triangle DAP. DAP. That means this part. This is the way triangle we have to take. Okay, DAP and EBP. EBP. These two triangles are equal. That's what we have to prove. One more, we have to prove AD equal to B. AD equal to B. Okay. So here we have to consider these two triangles first, and we have to prove that two are what? Congruent. Okay. So this question also similar as the previous one, because if we are considering this way the triangle, okay, then here is the next triangle. Okay, so here this one and this one. Okay, and here the common part is missing there, common part. That means this common angle, okay, for both the triangles, that is the common angle. So if we are adding this common angle with both the angles, okay, so we can say in this complete triangle, angle P is equal to the second triangle's angle P. Okay, so let us start. First of all, APE, they given that APE. Look, this one, that what we are writing. So solution we are starting. So angle APE is equal to angle BPD. This is given. That means this given. Okay. So these two angles are equal. Now with this we are adding equals. We are adding. Okay. So angle APE plus EPD we are adding. Angle EPD is equal to this equal sign, then this angle BPD, and the same angle we are adding, angle EPD. So these two angles are equal and equals we are adding. So this two angles is sum. It is what? APE. That means this half and the other half. That means the complete angle of P. That means APD. So when we are adding these two, we are getting angle APD is equal to angle BPE. Okay. So these two corners are equally given. Now we have to consider the triangle. In triangle DAP and triangle EDP, angle A and angle B are equal. So angle DAP, in that which angle? Angle DAP is equal to angle EDP given. Okay, these two angles are equal, that given. Now next, these two angles only they given, but we proved here the complete angles are equal. Okay, so that is the second thing they given. In between these two line segments, that means the distance from A and P, this distance, and P to B both are equal. No, what is the reason? Because in question they given P is the midpoint of AB. If this point is the midpoint, so these two lengths are what? Equal. Okay, so next one we will take the side. In this triangle, the side AP and the side BP equal. How we understood B is the midpoint? What is the reason? P is the midpoint of AB. Because of that, these two line segments are, or these two sides are equal. Now the third side we will take angle APD, that is equal to angle BPE. Proved above. Here we proved that. So here we will write proved above. Proved above. This one is angle, this one is side, and this one is angle. So using this criteria ASA, we can say these two triangles are congruent. So therefore triangle BAP congruent to triangle EBP by ASA congruency rule. Okay, because of that it is congruent. So first part we proved. Now the second part AD means this side, and BE. Okay, so that two sides are equal or not, that what they are asking. Here we proved, since we proved here these two triangles, okay, these two triangles are congruent. So these two triangles sides are that to look AD and BE or EB, both are equal. No? What is the reason? CPCT. So we can write that. Second part we can write here. Second one, AB is equal to BE because of CPCT. That's all. Hence we proved. Hence we completed question number 7. Now move on to the last question from that exercise, 8th one. Okay. In right triangle ABC. So this is the right triangle. In right triangle ABC, right angled at C. Yes, it is right angled at C. M is the midpoint of hypotenuse. So if we are considering this as the right angle triangle, so AB is the hypotenuse and M is the point on AB. Where it is at the midpoint. M is the midpoint of hypotenuse AB. That means what is the length of AB? M it is correct in the center. That means these two distances are equal. That is the meaning of midpoint. No. Now continue. C is joined to M. That means this is the triangle. No, right angle triangle. So C is joined to first M, then it is extending to D, produced to a point D such that DM and CM both are equal. Okay, point D is joined to point B. So this point D is joined to point D. Then only the figure is look like this way. Okay, then what all things we have to prove? 4 things, total 4 things we have to prove. First one, triangle AMC, that means this triangle, and triangle BMD. So these two triangles are congruent, that what we have to prove first. Okay, so from the figure we will just look carefully, we will observe the figure and which criteria is suitable here. Let us look. So here these two triangles, these two sides are equal and these two sides are equal. So two sides we got. Okay, then what about this angle? That two angles are also equal. No, what is the reason? vertically opposite angle. Because of that, two angles are equal. So side angle side. Okay, using that criteria, very simple way, we can prove these two triangles are congruent. Okay, so let us write that. So solution, we are starting in triangle. These two names itself, triangle AMC and triangle BMD. In these two triangle, first one AMC. AMC is this side. Okay, so in that sides, if we are considering AM first, so AM is equal to DM. Sorry, BM. It is given. Okay. Now next, side angle side. No, now angle we have to take. Angle, these two angles are equal. So first this triangle we have to take. We have to maintain the order of the angle or triangle every time. Okay. So this triangle's angle we have to take. So that is angle AMC is equal to angle BMD. What is the reason? Vertically opposite angle. That information they are not given. That we observe and we find out. Okay, so that's what we have to write the reason. Vertically opposite angles. Vertically opposite angles are equal. That we know. So that is the reason. Now side over angle over. Next one, it is the side. So which side we not taken, that have to take. AM we taken. AM we taken. Now this one. CM. CM is equal to CM is equal to DM. DM, that also given. So side angle side, because of that criteria. So therefore these two names, triangle AMC is congruent to triangle BMD because of SAS criteria. Okay, so very easy way we proved this. Now move on to the second part. Angle DBC is a right angle. That's what we have to prove. DBC, where is DBC? DBC. That means this corner is 90 degree. We have to prove. When we are looking that figure in the first sight itself, we will understood that this is 90 degree, because like that way we drew that. No, this corner is 90 degree, that corner also 90 degree. But by looking way we understood. We have to prove that it is 90 degree exactly. Okay, so let us start. So which way we can start? Already we said these two triangles are congruent. That knowledge with us. Okay, these two triangles are congruent. So if that two triangles are congruent, already we proved. So what about these two angles? These two angles. In these two triangles, all the three angles and all the three sides are equal and equal. No, by CPCT. So we can say these two angles are equal by CPCT. Okay, so that we can write. So since we proved, since triangle AMC is congruent to triangle BMD, which implies this angle MAC, angle MAC is equal to, in this triangle, this corner, that means MBD, angle MBD. What is the reason? Because of CPCT. Okay. Now with these two angles, if we are adding this common part, okay, these two angles are equal, and if equals are adding with equals, the entire angles are equal. No? So that's what we are doing. We use this method in the previous two questions. So same logic we are applying here. So that means angle, this angle MBC, that angle we are adding. So what will happen? That means adding angle MBC to both. So here angle MAC plus angle MBC equal to angle MBD plus angle MBC. Now let us look these two angles. MAC, MAC, that means this corner, plus MBC, MBC, that means this full angle. Okay, with this angle, if we are adding this angle, so this full angle is coming, no? That means angle ACB is occurring. When we are adding these two parts, so the complete angle is getting, triangle it is getting. So we can write which angle is here? Angle C. So angle ACB, that is equal to, here when we are adding these two, angle MBD, MBD, that means this corner, plus MBC, MBC, that means this full corner is coming, this angle B completely coming. Okay, so that is what angle DBC. Okay, now in question they clearly said this is the first triangle they give, no, and this is the extension part. Okay, so in this they already said angle C is 90 degree, or it is right angled at C, that means this corner is 90 degree, that means angle ACB is 90 degree. Okay, and that is equal to angle DBC. Okay, so here you just look which is the angle we have to prove. Angle DBC. Angle DBC is a right angle. We got 90 degree, no? So hence prove that. Okay, so the second part also we done. Now move on to the third one. Okay, now in the third part, angle DBC. Now where is angle DBC? First of all, triangle DBC we will locate. DBC, DBC, that means this angle DBC. Okay, this side, this way we are taking the angle. Then ACB. Okay, so ACB I am just drawing separate way. I am just drawing, actually these are not separate, but we have to look, we have to separate that. That's why only I am just drawing separately. Okay, so here it is what? ACB. Okay, these are the two triangles we have to imagine, and these two triangles are congruent. That what we have to prove. Okay, now what all informations they given and already we proved, everything we will combine and we will try to prove this too. Okay, so in this two triangles, see these two sides are already the part of the first two triangles, because first we consider these two triangles, no, these two triangles are congruent, already we said. Okay, so this is the third side. These two cases already when we mentioned, but we not mentioned the third side there, so here we needed that. Okay, so we can take these two sides are equal. What is the reason? CPCT. Okay, so that means this one and this one, this side are equal. Okay, now just above here in the second one we proved, already we know angle C is 90 degree because that is given, and in the second part we proved B is also 90 degree, so that two corners are equal, 90 90. Then what about this BC? You just look the name, here also BC, here also BC. Its meaning it is what? That is common, no? Yeah, common. So which criteria we can use here? Sides 2 times came and the corner, that means the common corner, common angle. So SAS, because of that two criteria, these two triangles are what? Congruent. So we will write that. So which two triangles we are considering, that two names we have to write here first. Okay, so in triangle DBC and triangle ACB, we will take the sides. So DBC means which side? DBC, this side. Okay, so we will take side DBC. So side DB is equal to side AC. Okay, because of CPCT. Okay, now angle B and angle C are equal, proved in part 2. Okay, so that we will write angle DBC is equal to angle ACB from 2, directly we will write from 2, from question number 2. Okay. Now BC, it is common. So the side BC equal to BC, reason it is common. So this is the side, this is the angle, and this is the side. So therefore these two triangles, triangle DBC is congruent to triangle ACB. Which criteria? SAS criteria. Because of that criteria, these two triangles are congruent. Okay, so third part also successfully we proved. Now the last and final part, CM is equal to half of AB. Okay, so let us prove that also. Already we proved these two triangles are congruent. These two triangles are congruent. Okay, that means this is the way we observe. No, these two triangles are congruent, and we use SAS. That criteria we use. No, and this side we not use. These two sides we not use. That are also equal by CPCT. That means from this what we understood. That means AB and BC, they are equal by CPCT. Okay. So that we will write, since triangle DBC is congruent to triangle ACB, in these two triangles DC is equal to AB. What is the reason? CPCT, because already proved, no, that two triangles are congruent. So because of that. Now DC the side DC, M is the midpoint, and already we marked here these two lengths equal and these two lengths are equal. So here DC means it is the sum of DM and CM. Okay, so this DC we can split and we can write like this way. DC, it is the sum of DM plus CM. Okay, which is equal to AB. AB we are not splitting because what statement we have to prove in that AB is there. Okay, so AB we are not splitting. Now we know DM and CM, they are equal. Okay, these two measurements are equal. So why two different names? One name is enough, no? So instead of DM we are writing here CM. Why we are using CM? 2 times we can write DM, no? 2 times we can write DM, but you just look in the statement there they use CM. Okay, so we will avoid DM and we will, instead of DM we will use CM. Okay, so DM that is equal to CM and here also CM. That means both are equal. So why two names? Same name we will use, EM plus CM. Okay, that is equal to AB. Okay, now why we use the instead of DM CM itself? Its reason, writing here, its reason it is what? M is the midpoint of DC. Okay, because of that two are equal. Or in figure given these two are equal. Okay, so reason we written. So 2 times CM meaning it is what? 2 CM, that is equal to AB. Now this 2 we can shift to the other side. No, we can transpose this. So this 2 it is here in the multiplication operation. It is here in multiplication. On the other side it will be move on to division. So CM is equal to AB by 2. That meaning it is what? Half AB. So this itself we have to prove. No, hence we proved. So this is the solution for the 8th question. In 8th question itself 4 subdivisions are there. Everything we proved here. Hope you understand. Okay, thank you.